Hi, I'm Mr. V, and today we'll be talking about Unit 6 from Illustrative Mathematics in Geometry, Coordinate Geometry, and Lesson 6, Completing the Square. We're going to start by talking about some of the homework problems from the previous night, and this is one of them. It says, given a circle, and this should be a y, they typed it in as an x, it should be a y. The equation of circle, what is the radius and what is we'll also ask what is the center. If it were in this form, we could do this readily. And you'll notice that here I have these three terms makes a perfect square trinomial. These three terms makes a perfect square trinomial. And what do I mean by that? Well, if you have x plus a and you square it, that's the same as x plus a times x plus a. And to show you what this is equal to, I'm going to use the area model, the box, and to show you what this comes out to. So we'll have the length and the width of this box. We have x plus a, and we have x, and I'll put the plus sign next to the a. When I multiply the length times the width, I get the area. So x times x is equal to x squared. A times x is equal to ax. A times x is equal to ax over here. And then we have a times a is equal to a squared. So this is a binomial squared. And when we rewrite it, notice these two terms can be combined. We could also write this as x squared plus 2ax plus a squared. Well, the 2a is going to be the coefficient of my x value. And a squared is the missing term to make this a trinomial, what is called a perfect square trinomial. Why? Because this is a square of length a plus x plus a. So I could write this as x minus half of this is 4 squared. And I could write this one as y plus 5 squared is equal to 9 squared. And now it's in this form. So if I look at and if I wanted to, I could write this right next to it. That might be helpful for determining what h and k is and to determine what the r is. Well, the h and the k, x minus h, x minus 4. My h is going to be 4. Y minus k, this is y plus 5. So minus k is equal to plus 5. That means that k is equal to a minus 5. And my radius is equal to 9. Also from the homework, it said to graph the circle. Well, the center of this circle, my hk value, is equal to 2 and 1. And it has a radius is equal to, this is r squared, so r is equal to 5. So if I go 2 and 1, and I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, down this way 5, and to the left 5, I could draw this circle something like this. Something like this. There you have it, something like that. Again, if I square a binomial is two terms separated by a plus sign. I get a perfect square trinomial. There's three terms, tri, and it's separated by a plus or minus sign. So with this in mind, we go to our class. All of the class assignment was in Desmos, coordinate geometry. But at the end of the lesson, the objective was that you would be able to find the center and the radius of a circle by completing the square. So the bell work, or the initial work that we did today, the warm-up, was for each expression to tell what value would make this a perfect square, trinomial. And I'm going to do this on my whiteboard. So we know that this coefficient of the x term is equal to 2a, and I'm looking for a squared. So half of this is 5. When you square it, you get 25. Half of this is negative 8. When you square it, you get 64. Half of this is 20. When you square it, you get 400. Half of this is 5 halves, or you could write it as 10 fourths, or you could write it as 2.5. Any way is fine. When you square it, you get 6.25. Okay. We compared each other's answers and talked about them. Then we went to this exercise. So in this activity, we are going to complete the square for the equation of a circle. Here's the original equation. This is the equation of a circle. It doesn't look like the familiar form that we like to use. And the idea is to rewrite it in that form by completing the square. And this is what Elena did. First of all, she did this step, then she did this one, and then she did this one. And we're supposed to say, what did she do in the first step? What did she do in these other steps? And I should actually copy this right here over so you can see what the original was that she was given. And now I'm going to go to my whiteboard again, and I will move this down and copy. This is my original equation. And what did she do to go to step 1? Well, several people noted, and you might notice this as well, she swapped the place of these two terms. So the x's are like close in proximity, and the y's are close in proximity. And she subtracted 105 to get it to the other side of the equation. So if you subtract 105 from both sides of the equation, you get there. And then she added 9 and 100. And she did that to both sides. Why? Because it's a property of equality. Anything you do to the left side of the equation, you have to do to the right. She added 9 because that makes this a perfect square trinomial. She added 100 because that makes this a perfect square polynomial. And when you add this together, you get 4. So I can write the left side of the equation as x. This is a minus, half of this is the -3. And when you square it, you get your 9. And I get, this is x plus a, remember? Y, and this is going to be a -10, or plus or minus 10, is equal to, and my r is going to be 2 squared. So my center of this is at 3, 10, and my radius is equal to 2. And we can do this on the Desmos down here. 3, 10, this is my center. I'm going to draw the circle. It's going to have a radius of 2, so it's going to go from here to here, down and around, like that. When we add something to both sides of the equation, this is applying a property of equality. And you know what the properties of equality are. So this is the addition property of equality when you add. When you subtract from both sides, it's the subtraction property of equality. When you divide, the division property of equality. When you multiply, the multiplication property of equality, because it keeps the equality the same. So they're equal for both of these. Now, you could also square both sides of an equation or square root both sides. And we do even more of that with logarithms and other things. But the idea is anything you do to the left side of the equation, you do to the right. And when we do it here, it's called completing the square because it makes what we have to 2 perfect square trinomials, one with the x's and one with the y's. So here are some questions to discuss. Why do you think we wanted this form? We wanted this form because we want to know what h and k is. This is the center of the circle. We want to know what r is, which is the radius of the circle. And in this form, you can look at the equation and know that. Why did she do step 2? Why did she do step 3? Anyway. Now here's another question for you to try. This is with this equation. You're going to do what Elena did and rewrite this into the formula. I'm going to do it right here, but you should try it on your own first if you're listening to this tape. So the first thing that she did was she added 4 to both sides, and she switched places to put the x's and the y's closer in proximity. So we have x squared minus 2x. I'm going to leave a space here for the completing the trinomial, perfect square trinomial, plus y squared plus 4y, and I'm going to leave a space here, is equal to, and I'm going to add 4 to both sides. So I have 4. Well, what do you add to this to make this a perfect square trinomial? And what you're going to add to it, let's see, half of -2 is -1, and -1 squared is 1. So I'll add 1 to both sides of the equation. Here we have half of 4 is 2. And when you square 2, you get 4. So I'll add 4 to both sides of the equation. And what this becomes, this would be a perfect square trinomial. So it's x minus 1 squared. The binomial squared is equal to my perfect square trinomial because this is a square. And then we have y plus 2, which is half of That's my a value, y plus the 2 squared, which would give me this trinomial, is equal to 9. So I know that from this, my hk value, my center of my circle, is equal to 1, negative 2. And my radius is equal to 3. And I can draw that on the graph by going 1, negative 2, and using 3 as my radius. 1, 2, 3, 1, 2, 3, 1, 2, 3. And I can draw the circle, something like this. Something like that. If you want to do more, you can do this on the next page. There, you can write the equations of the circles here. One with a center at 3, 4 and has a radius of 5. One with a center at 11 and negative 4 has a center of 13, and one with a center of 21, 16 from 7 with a radius of 17. So if I did 3, 4, and 5, I could type in x minus 3 squared plus y minus 4 squared is equal to 5 squared. And there's my circle. If I wanted to make this smaller, you can see it. There it is. And you can see the coordinates of some of these points: 3, 9, 3, 8, 0, 0, 3, negative 1. Anyway, you find all three of them, and this is one of those more activities. It's meaning it's an enhancement activity. Lesson synthesis. Look at these two equations. What makes them different from the ones that we've seen before? You think about this and then answer this question. You'll notice this x squared does not have an x term next to it. And here we have everything is equal to 0. We've done it equal to 0 before. We could subtract 143 from both sides and then complete the square on each of these. But wait a minute. What does this not having an x term imply about the h coordinate of my center of my circle? There is no x minus something squared. It's just x squared. So it's x minus 0. This means that this would be 0. In fact, if I had an equation x squared plus y squared is equal to 9 or is equal to 3 squared, I would say, well, the center of that is at 0, 0. That's what the implication is here. Here we got some big numbers, but we know how to deal with this. The question is, what about this guy? This is not a perfect square. And I'm not going to square 19. This is r squared. So if I square root both sides of the equation, I would get r is equal to the square root of 19, which falls between what two consecutive whole numbers? It's between 4 and 5, somewhere around like 4.4 or something like that. But it's the square root of 19, so it's not a nice number, not necessarily. And there's one more that we can do, which is from the cool down, and I will do this on my whiteboard to show it to you here. Oh, we're supposed to find the circle of the center of both of these. Let's just do that real quick. So I'll subtract 143 from both sides of this equation, and I will go get x squared plus y squared minus 24y, and I'll leave a space for the completing of the trinomial, is equal to negative 143. Half of 24, negative 24 is negative 12. When you square it, you get 144. Anything I do to the left side of the equation, I do to the right, so I will add 144 to this side of the equation. And now I have x, if you want to write it x minus 0, you could. X minus 0 squared plus y minus 12, that's half of this number, this is my a value, squared, is equal to 1. My center is at 0, 12, and my radius is 1, because that's 1 squared. For this one, my center is at negative 35, 50, and my radius is equal to the square root of 19. And the last one, which is the cool down, again, let's see, I'm going to combine these two like terms. So I have x squared plus 12x, and I have plus y squared plus 2y, and I'll subtract 12 from both sides, is equal to negative 12. What do I need to complete the square here? Well, half of 12 is 6, and 6 times 6 is 36. Half of 2 is 1, and 1 times 1 is 1. And anything you do to the left side of the equation, you have to do the right, so I'll add these both to this side. And I get from my equation that x plus 6 squared this is my squared binomial, perfect square trinomial, plus y plus 1 squared is equal to, let's see, this is 25. Or I could write that as 5 squared. So my center of this is going to be equal to negative 6, negative 1, and my radius is equal to 5. And that's all I've got. Please look over the lesson summary, and good luck and success.